ఫ్యాన్లు బంద్ చేయి. So dear students, in the last class I was telling, when carbon uses ground state electronic configuration, then the carbon can form two bonds with this one and this one. Means it exhibits divalency. Whenever carbon exhibits divalency, that carbon has one lone pair. Compulsory. Means what? When carbon shows divalency or trivalency, then that carbon will always have one lone pair. Now, when carbon uses first excited state electronic configuration for bonding, then that carbon has 4 half-filled orbitals. With the 4 half-filled orbitals, it will form 4 bonds. When carbon forms 4 bonds, then lone pairs will be how many? 0. It means whenever carbon exhibits tetravalency, then in that carbon number of lone pairs are 0. It means here lone pairs 0, here lone pairs 0, here lone pairs 0, here lone pairs 0. Now these single bonds are called bond pairs. In chemical bonding, you might have studied that only sigma bonds are considered as bond pairs. Therefore 1, 2, 3, 4 sigma bonds, then bond pairs are 4. Here this is a pi bond. Pi bond should not be taken into account. So now sigma bond, sigma bond, sigma bond. Only sigma bonds are considered as bond pairs. Therefore bond pairs here 3. So here this is one sigma bond, this is another sigma bond, then bond pairs here 2. Here this is sigma, this is sigma, this is pi, this is pi. Here bond pairs 2. Here total number of electron pairs 4 plus 0 4. Total number of electron pairs 3 plus 0 3. Here total number of electron pairs 2 plus 0 2. Here total number of electron pairs 2 plus 0 2. Whenever number of electron pairs are 4, then that carbon undergoes sp3 hybridization. When number of electron pairs are 3, then that carbon undergoes sp2 hybridization. When number of electron pairs are 2, then that carbon undergoes sp hybridization. When number of electron pairs again 2, this carbon undergoes sp hybridization. So here in an organic compound, if carbon is forming 4 single bonds like this, then that carbon hybridization is sp3 type. In an organic compound, if carbon forms a double bond and single bond, then that carbon hybridization is sp2 type. In an organic compound, if a carbon forms a triple bond and single bond, then that carbon is sp hybridized. In an organic compound, if carbon forms 2 double bonds, then that carbon is sp hybridized. So, taking this into consideration, now you have to tell which carbon undergoes what hybridization whenever any problem is given like this. So in JER NEET, you will get this kind of problems. For this, now see, let me take one organic compound. Carbon, how many bonds? 1, 2, 3. 3 bonds like this. Then bond with another carbon. Then bond with hydrogen. Then bond with carbon. Because always around carbon you have to write 1, 2, 3, 4 bonds. Then with carbon, then hydrogen, hydrogen, then with carbon, then with carbon, then with carbon, 3 hydrogens. Here also 3 hydrogens. Then bond with carbon, 1 bond with hydrogen, then double bond with carbon, 1 bond with hydrogen, then single bond with carbon, then 2 bonds with hydrogen, then triple bond with carbon, then single bond, then bond with carbon, 3 hydrogens, then carbon, hydrogen, hydrogen, then C double bond O, OH. So here, this is one organic compound I have written. This organic compound can be in short written as, this total is written as CH3 bond, this is written as CH bond CH3, this one, bond CH2, this one, then this is CH3, then again CH3, then CH double bond CH, CH2, triple bond C, then CH, then CH3, then CH2, then COOH. Like this also, this compound in short can be written like this. Then more shortly, how you write this CH3 in bracket, then CH, then the CH3 in bracket, then CH2, then C in bracket, CH3 taken twice, then CH, CH double bond CH, then CH2, then C triple bond C, then CH, then in bracket CH3, then CH2, then COOH. Like this also in short. So this organic compound, complete structure. Then compressed structure. This is more compressed structure. But there is another method of writing organic compound. It is called as bond line notation. Bond line notation means, in this we don't show hydrogens and we don't show carbons. Other than carbon and hydrogen, if any oxygen is there or sulfur is there, nitrogen is there, that atoms we show. But carbons and hydrogens are not shown. They are only imagined. How? Every corner is believed to be having a carbon atom. Every corner is believed to be having a carbon atom surrounded by required number of hydrogens. Every carbon is believed to be having a carbon surrounded by required number of hydrogens. See here now. I don't write these hydrogens and I don't write this carbon, but I will just put a corner. It means here there is C surrounded by 3 hydrogens. Then this is another corner. To this CH3 is attached. So this is C surrounded by 3 hydrogens. Then this is this C surrounded by 2 hydrogens. Then this C. Then CH3. Then this CH3. Then this C. Then this double bond. Then this C, then single bond, then CH2, then this C, triple bond, then this C, this one is here, and to that again a CH3 is there, then CH2, then this C. But how is that C? That C is bonded to oxygen, that I will write. And the same C is bonded to OH, that I will write. This is called bond line notation of this compound. So now here, which carbon undergoes what hybridization? C carbon 4 single bonds. This is sp3 hybridized. This carbon 1, 2, 3, 4 single bonds, sp3. This is also sp3. This is 4 single bonds, sp3. This is sp3. This is sp3. This is sp3. But here 2 single bonds and a double bond, it is sp2. Now double bond and 2 single bonds, sp2. 4 single bonds, this is again sp3. Triple bond and single bond, sp. This is sp. This is sp3, sp3, sp3. But again here, this carbon, 2 single bonds and 1 double bond, it is sp2. So this oxygen is outer other atom, therefore no hybridization. But here it is like water structure. 2 bonds means it has 2 lone pairs. 2 lone pairs, 2 bond pairs, total number of electron pairs 4. This oxygen also sp3. Like this, we identify the type of hybridization on the carbon atom. Okay? Then, how is this bond formed? By the overlapping of half-filled sp3 hybrid orbital of this carbon with s orbital of hydrogen. Therefore, this bond is sigma sp3-s. This is sigma sp3-s. This is sigma sp3-s. But this is sigma sp3-sp3. This is sigma sp3-sp3. Sigma sp3-s. Sigma sp3-s. Sigma sp3-sp3. Sigma sp3-sp3. sp3-s, sp3-s, sp3-s. sp3-sp3. sp3-s, sp3-s, sp3-s. sp3-sp2. This is sigma sp3-sp2. Then this is sigma sp2-s. This is now sigma sp2-sp2. This bond is sigma sp2-sp2 and this bond is pi pp. This bond is sigma sp2-sp3. sp2, this is what? sp2-sp3. So this is sp3-s, sp3-s. Now this one, this is sigma sp3-sp. Now this one, this is sigma sp dash sp. This one is pi pp, this is pi pp. Now this one is sigma sp dash sp3. Now this is sp3 dash s, sp3 dash sp3, sp3 dash s, sp3 dash s, sp3 dash s, sp3 dash sp3, sp3 dash s, sp3 dash s, sp3 dash sp2. Now this is sp2 dash p. This is sigma sp2 dash p. This is pi pp. Now this is between carbon and oxygen. Now sigma sp2 dash sp3. Now oxygen and hydrogen sp3 dash s. So this is an sp3 hybrid orbital carrying lone pair, sp3 hybrid orbital carrying lone pair. So this is bonding, structure and bonding in organic molecules. This is structure and bonding in organic molecules. But in the exam, like this clear-cut expanded structure he don't give. Always in the exam he will give bond line notations like this. So now I will give another bond line notation. Then you have to predict type of hybridization, how many sigma bonds are there, how many pi bonds are there, sigma and what type, pi what type, all these things you have to tell. Now here, this is central carbon, 4 single bonds, sp3. Then this becomes CH3, therefore this is sp3. CH3, this is sp3. Here also CH3 means 1 single bond and 3 single bonds with 3 hydrogens. Then this is sp3. This is sp3, but here this is double bond and 2 single bonds. This is sp2. This is sp3. This is sp2. This is sp3. This is sp. This is sp. This is sp2. This is sp2. This is this is sp. This is sp2. This is sp2. This is no hybridization. This is sp3. This is sp3. Here sp2. sp2. This is sp2. Then this nitrogen has 1 lone pair and 2 bond pairs with 2 hydrogens. So 3 bond pairs, 1 lone pair. Total number of electron pairs 4. Hybridization is sp3. Like this I will predict. Now total number of pi bonds. Very easy question. Here 1 pi bond. Second, third, fourth, fifth, sixth, seventh, eighth. So number of pi bonds 8. Then number of sigma bonds. Here 3, here 3, here 3, then here 4. So totally, then here there are 2 hydrogens now. So this is also, so here 3 plus 3 6 plus 3 9 plus 4 13 14 15 16 17 18 plus 3 21 22 23 plus 3 26 27 28 then one bond with hydrogen 29, here one bond with hydrogen 30 31 32 33 34 plus 3 37 38 39, then this is here with hydrogen 40 with hydrogen 41, then 42 43 44 45 46. So total number of sigma bonds 46. So now like that the question is sigma sp3 dash s how many, means what? sp3 overlapping with s orbital of hydrogen, this is, they are how many? Then sigma sp3 dash sp3 means this is sp3 dash sp3 sp3 dash sp3 sp3 dash sp3 sp3 dash sp3, like that how many? Sigma sp3 dash sp2 how many? This is sp3 dash sp2. Then sigma sp2 dash sp2 how many? This is sp2 dash sp2. This is sp dash sp. This is sp2 dash sp. This is sp dash sp2. This is sp2 dash sp, sp dash sp, sp dash sp2. This is sp2 dash s. Sigma sp2 dash sp2. This is sigma sp2 dash p. This is sp2 dash sp3. Sigma sp2 dash sp3. Sigma sp3 dash sp3, here again 3 are there, sp3 dash s. So here sp2 dash sp2. sp2 dash sp2. Here this is sigma sp2 dash p. This is sp2 dash, means what, this carbon nitrogen bond is what? sp2 dash sp3 overlapping sigma. Then this is sp3 dash s, sp3 dash s. Like this we can predict the type of bonds, and this is all called as structure and bonding in organic compounds. Now here we have like this carbon double bond oxygen. If it is not there, instead of that it is CH2, like this, an ordinary chain. So like this now. This will have one type of properties. But here if it is double bond, then this functional group it has another type of properties. It means what? Presence of this particular area in the organic compound, this one, will completely changes the nature, physical properties, chemical properties, behavior, everything. It means what? This is called nature governing group. Nature governing group. Now this is another one now. It is written as C double bond O NH2, or in short it is written as CO NH2. So this group Presence of this group will give another different type of properties to the organic compounds. So, such a group present in the organic compound which decides the nature of the organic compound, or we can say the atom or the group present in the organic compound based on which properties of the organic compound are dependent. That group is called functional group. So functional group is called nature deciding group. So now I was telling what is a functional group. So like this now, I have a compound like this, CH3, CH2, CH3. Now here it is all means between two carbons, all are single bonds. Then this is another one, CH3, CH2, CH2, CH3. Here single bond, single bond, single bond. This is CH3, CH3. Single bond again. Then CH3, CH2, 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 CH3. Now, all these compounds, general formula is Cn H2n plus 2. In all these compounds, Cc is a single bond. Such compounds are called alkanes. Now, all these compounds called alkanes have similar properties. But if you observe, the difference between these two is CH2. Difference between these two is CH2. Difference between these two is CH2. So, it means a series of organic compounds having similar properties represented by some general formula, and the two successive members differ by the CH2 group is called as a homologous series. Homologous series. A series of organic compounds represented by some common general formula having similar properties and similar structure, and the two successive members differ by CH2 is called as homologous series. So name of this homologous series is alkanes. Now CH2 means carbon atomic weight 12, hydrogen atomic weight 1, another hydrogen 1, total 14. It means in the homologous series, the two successive members differ in the molecular weight by 14. These two differ by 14 molecular weight. These two differ by 14 molecular weight. These two differ by 14 molecular weight. So all the members of homologous series are represented by general formula. All the members of homologous series will have similar chemical properties. All the members of homologous series will have similar structure. Two successive members of homologous series differ by CH2. Two successive members of homologous series differ in the molecular weight by 14, and they have same chemical properties. Now, I will make it now CH2 double bond CH2. It is called ethene. See here, they are all alkanes. This is ethane, this is propane, this is butane, this is pentane. They are alkanes. Now this is ethene, and this is propene, and this is butene, and this is pentene. So they are all called alkenes. They are represented by general formula CnH2n. This is another homologous series. Now, these are having one type of properties. Because of this double bond, these are having another type of property. See, these are like alkane, single bond, everything is like alkane, but here there is a double bond. This double bond makes its nature different. This compound is same as this one. Means this compound should have same properties. But in this compound, here there is a single bond, here there is a double bond. Because of this double bond, this compound's chemical properties will become differ from this. It means now this double bond is called nature governing. Means double bond will decide the nature of the compound. Therefore, double bond is called a functional group. So, C double bond C is considered as a functional group, and this functional group name is ene group. So, just like that, this is just like that. Now I was telling this is alkane called N-pentane. This is alkene called N-pentene. Now this is having a functional group called ene. Now this is an alkyne having a functional group. Now because of this triple bond, its properties becomes differ from above two. Therefore this is another functional group called ene functional group. Okay, now what I will do, I will keep again 5 carbons as it is, but I will keep here OH group. Now this OH group is called alcohol functional group. Means presence of everything is here, this is all part same as this, but presence of this extra fellow, this is called nature deciding fellow. It will make the properties of this entire compound different, and this is called as functional group, and name of this functional group is alcohol functional group. Okay, now let me tell you another example for a homologous series called, name of the homologous series, homologous series, name is alkyl alcohols. Now their general formula is, every homologous series is represented by general formula, then that is CnH2n plus 2 is alkane actually. This is alkane, but in place of one hydrogen I am having a functional group called OH. This is functional group. Okay, this is now, but you know CnH2n plus 2 is called alkane. From this, if I minus or if I subtract one hydrogen atom, then I have CnH2n plus 1 and one bond is hanging in the air. Here was the hydrogen that is removed. Now this, its name is alkyl group, and alkyl group is represented by R. So this name is alkyl and this is alcohol, that's why it is called alkyl alcohol. That's why general formula of this alkyl alcohols also I will write as ROH, because this CnH2n plus 1 is represented by symbol R. So general formula is ROH. Now R is CH3 and OH. This is methyl alcohol. Then R is CH3 CH2OH. This is ethyl alcohol. R is CH3 CH2 CH2OH. This is N-propyl alcohol. 1, 2, 3, 4. This is butyl alcohol. 1, 2, 3, 4, 5 pentyl alcohol. So now this is homologous series alcohols. Now these two will differ by CH2. These two differ by CH2. These two differ by CH2. These two differ by CH2. Therefore, it is called as a homologous series named as alkyl alcohols. Okay. So this is all about the basics of organic chemistry. Then I told in organic chemistry there are millions of compounds. Millions of compounds, their names, how do you remember? Nobody will remember. So therefore, to write the name of the organic compound, we have one method called IUPAC system of nomenclature of organic compound that is followed after this. Okay? So, in the last class I was telling that in the next class I am going to start nomenclature of organic compounds. So dear students, now let me start how to name an organic compound. So that we are going to study under the heading called nomenclature of organic compounds. Students, here he will give some organic compound, and based on the structure of the organic compound we have to write the name of that organic compound. And here structure is important because in organic chemistry, with the same molecular formula, there will be many compounds. For example, in inorganic chemistry, with one formula, we have only one compound. For example, if I say H2SO4, means it is none other than sulfuric acid. If I say H3PO4, it is none other than orthophosphoric acid. Whereas suppose if I say C5H12, it is pentane. It can be N-pentane, it can be isopentane, it can be neopentane. So like that, with the same formula, so many organic compounds exist. That is what is called isomerism. Isomerism means different compounds have same molecular formula, but they are not same compounds. Therefore, their names will be different. Therefore, in organic chemistry, we write the name of the organic compound based on the structure of the organic compound. So here, structure of the organic compound is important. So, let me take some structure like this: CH3, C, CH3, double bond, CH, CH3, then C, CH3, CH3, then C, double bond O, CH2, COOH, like this. Now he will ask, what is the name of this organic compound? So, for naming the organic compound, we have to follow rules called IUPAC system of nomenclature of organic compounds. This is International Union of Pure and Applied Chemists. It has framed some rules. Here we need not by-heart the rules. We should follow the rules. When you follow the rules, then only you can name the organic compound. So what rules should be followed while naming the organic compound? So it says that first observe the structure carefully. Like this, I have observed the structure carefully. So now Here in this compound 1, 2, 3, 4, 5, this is one chain. 1, 2, 3, 4, 5, 6, this is another chain, or this is another chain, or 1, 2, 3, 4, 5, 6, this is another chain, or 1, 2 straight one, this is another chain. Like that, we have different chains. We have different chains. In these chains, we have to observe what is main chain and what are side chains. Okay? So now, so that is called, after observing the organic compound structure, we have to select the what is called main chain. After selecting the main chain, suppose now this is the main chain I have selected. After selecting the main chain, all other chains, they become called side chains. So like that, in the organic compound, first you have to select the main chain and remaining all chains will become side chains. These side chains, they are also called as substituents. So now, question is, how do you select the main chain? In that main chain, in the so many chains, in which chain maximum number of carbon atoms are there, that is called as longest possible chain. And longest possible chain should be selected as the main chain. That is called as long chain rule. So, in the organic compound, we have to observe the structure and see in the structure which chain is the largest chain, which chain is having more number of carbon atoms. That chain is selected as main chain, and remaining all chains will become side chains. So here first thing is longest possible chain is selected as the main chain. Now CH3, 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 then CH2, CH3, then CH2, CH3, then this is another CH3, then CH2, CH3, like this. Now if you observe here, 1, 2, 3, 4, 5, 6, this chain is having 6 carbons. Then 1, 2, 3, 4, 5, 6, 7, 8, this is having 8 carbons. Then 1, 2, 3, 4, 5, 6, 7, 8, this is also having 8 carbons. So then, but after observing everything, what I came to know is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this chain is having 9 carbon atoms. Therefore, this is the main chain. So now, after that, this will become side chain, this will become side chain, this will become side chain, this will become side chain. Like this, you have to select the main chain. But suppose if there is a now this is the organic compound. See, if you see 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is having 8 carbons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then 1, 2, 3, 4, 5, 6, 7, 8. This straighter one also having 8 carbons. Then if you take like this also, it is having 8 carbons. Then if you take 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So here, this is also having 8. Now, which one should be selected as main chain? Then the rule is, the chain containing maximum, the chain that carries maximum number of side chains will become the main chain. If you observe the straight one, 1, 2, 3, 4, 5, 6, 7, 8. Means this is side chain 1, side chain 2, this is total becomes side chain 3 it is having. Now, if you take this one, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. It is having 7. Okay. Then it is having 8. So now, this is 8, this is 8. But this is having 1, 2, 3 side chains. Or I will write here one more. Okay. Now, this is having 8 side chain. 8. This is also having 8. And this is also having 8. This is having 8. This is having 8. 1, 2, 3, 4. Okay. I'll write here, then it will become, all have 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, let it keep only this. Then, if you take this chain as the main chain, 1, 2, 3, 4. 4 side chains are there, that is maximum. So it means what? When same number of carbon atoms are present in different chains, then the chain carrying maximum number of side chains should be selected as the main chain. So that is the rule. So the rule is what? So second rule is chain carrying maximum number of side chains is the main chain. Chain carrying maximum number of side chains is the main chain. Then CH3, CH2, CH double bond, CH2, then CH2, CH3, CH2, CH3, then CH2, CH3. 1, 2, 3, 4, 5, 6, 7 carbons are there. 1, 2, 3, 4, 5, 6 carbons are there. 1, 2, 3, 4, 5, 6 carbons are there. So this is the longest possible chain, but this is not the main chain. Why? Because we have a functional group called ene that is going out of the main chain into side chain. But the rule is functional group should always be in the main chain. The rule is what? The chain containing functional group should be selected as the main chain. Or I can say the chain in which the carbon carries a functional group or some functional group is attached to a carbon, that chain should be selected as the main chain though the chain is short. So rule number 3 is the chain containing functional group, chain containing functional group is the main chain though it is short. इसका मतलब जिस चेन में फंक्शनल ग्रुप है वो मेन चेन है, even though that is shorter chain. Okay? Or I can say the rule like this: the carbon atom to which functional group is attached should be in the main chain though the chain is short. Means say, let me write one example here. CH3, CH, CH2, OH, here CH2, CH3, CH2, CH3. So longest possible chain is 1, 2, 3, 4, 5. This is longest possible because it is having 5 carbons. But 1, 2, 3, 4, this is having only 4 carbons. So though it is having 4 carbons, but this carbon to which functional group is attached, it should be in the main chain. So therefore this becomes the main chain and this becomes the side chain. So that is, the rule is the carbon to which functional group is attached should be in the main chain. Then After selecting the main chain, this is first point, that is selection of the main chain, and main chain is selected based on these rules. Okay, after selecting the main chain, the next is we have to give numbers to the main chain. What should we do? We should give numbers to the different carbon atoms present in the main chain. Okay. So here, first is selection of main chain, then second is numbering the carbon atoms of the main chain. How do you give numbers to this? Numbering is done like this. Say, we should give numbers of the different carbons as 1, 2, 3, 4, 5 in such a way that the carbon to which group of high priority is attached should get lowest number. It means what? Numbering of main chain in such a way that the group of highest priority should get lowest number. Now, for that I will give an example. This is CH3, this is CH, this is CH3, then CH double bond, CH, then CHOH, then CH3. So now here main chain is understood, that is 1, 2, 3, 4, 5, 6 carbons. This is the main chain, because now this chain is having this functional group as well as this functional group, and it is longest possible chain. It is having 6 carbon atoms. After that I can give numbers as 1, 2, 3, 4, 5, 6, or I can give this as 1, 2, 3, 4, 5, 6. How I should give? The rule is what? Highest priority group should get lowest number. OH group is high priority group compared to EN group. This is of low priority, this is lowest priority. Means this is not highest priority. Therefore, I should start giving numbers from this side to this side so that it will get 2, this will get 3, this will get 5. That is correct way. So I am numbering like this: 1, 2, 3, 4, 5, 6. So this is how I have to give number. But how do you know that which group is of high priority and which group is of low priority? For that you should know order of priority of different groups. So after knowing the order of priority of different groups, then only we can give numbers. So one should know order of priority of different groups. So now this is SO3H group. It is called sulfonic acid group. Sulfonic acid group. Its structure is S double bond O double bond O OH. This is of highest priority. Then C double bond O, OH. This is called carboxylic acid functional group. Carboxylic acid functional group. Or it is also written as COOH group. Let me write here short form. COOH group. And the structure is C double bond OOH. It is greater than C double bond OH group. Let me write short form CHO group. It is called aldehyde functional group. And its structure is C double bond OH. Greater than C triple bond N group. This is cyanide group. Greater than C double bond O NH2 group. Then this is amide group. Greater than C double bond O Cl group. C double bond O R. This is ester group. Greater than C double bond OX group. Greater than OH group. So like this we should know the order of priority of the group. If you know the order of priority of the group, then we can give numbers to the different carbon atoms. So knowing the order of priority of different groups is very important. So that order of priority and remaining thing I will continue. ఇప్పుడు మొత్తం ఇందులో 1 hour అయిపోయినా